All right, we're going to do a quadratic word problem, and we're going to start with this formula. Now, this is S of t equals negative 16 t squared plus v naught t plus s naught, okay? And it says that the initial velocity is v naught, and the initial height is s naught. And this is a formula that will always work if it's in feet, okay? In feet per second, okay? So those are the units that have to be used to be able to use this formula. There's another one, and we're going to write it up here above it. That's S of t equals negative 4.9 t squared plus 19.6 t. Oh, sorry, not 19.6 t. That was for a specific problem that we're going to do. Sorry. Negative 4.9 t squared plus v naught t plus s naught. So just like that, but instead right here, it's a negative 4.9. This is if it's in meters. And then the velocity is meters per second. Okay? All right, so for this particular problem, it says a ball is thrown directly upward. Okay, there we go. A ball is thrown directly upward from an initial height of 100 feet with an initial velocity of 80 feet per second. Okay, so we're going to stop right there, and we're going to go, ooh, initial height. That's S naught. And an initial velocity of 80 feet, that's V naught. And don't write feet per second when you fill it into your formula. That would just get confusing with your units. All right, give the function that describes the height of the ball in terms of time t. Okay, well the function is just this right here, but with the stuff filled in. So s of t, that's just like your f of t or your f of x or your y or anything else, okay? They just call it s. I'm not sure why it's called s when it's position. But anyway, so it's s of t equals negative 16 t squared, and then v naught t, so plus 80 t, plus S naught, so 100. There it is. Okay, now it says to graph the function on your calculator. Now remember, for anything online that we're doing, we're going to be using desmos.com. Okay, so that the y-intercept, the positive x-intercept, and the vertex are all visible. Sketch below, include your window. Okay, so I'm going to open up my computer, and I'm going to go to desmos.com. Okay, I'm going to start graphing. Okay, and then I'm just going to type it here. Now, this part, you're going to write y equals, not s of t equals. Okay, and then we're going to type negative 16 x, and then you're going to hit your up, maybe nope. Let's see, shift. There we go. So shift and 6, so the little caret symbol. Okay, squared, and then plus 80x plus 100. Okay, and that's what I'm looking at. And I'm gonna, well, let's see. Keep going, keep going, keep going, keep going. I think, well, you gotta at least get to 100 because you need, your y-intercept is 100, right? There it is. Hallelujah. 200. Okay, so now let's see. I wonder if we can graph settings. Okay, so there we go. So you go to graph settings, and then we go to x-axis. I definitely don't need that far to the left, so I'm just going to say 0 because it said the positive x-axis. If you're looking back here, it says the positive x-intercept, the y-intercept, and the vertex. Okay, so now let's see what this is. That's 6, 0, so I don't need to go that far right. So I'm just going to say like 10, which makes sense because if you're talking about something being in the air, 10 seconds is a long time for it to be in the air. All right, and then, oops, I just messed it up. Every time I scroll, it messes it up. Okay, step I think by ones is nice. Okay. So that just means we're just going to count by on the there. Okay, now we need to go from 0 to, I mean, that's what, 200? So let's just go to like 210, just to get a little above it. And let's go -10 just so I can see my x-axis. There we go. -10 to 210. Right, now you can see your x-axis and you can see your y-axis. Maybe let's go a little bit low, -1. There we go. Just so I can like see the full thing. Okay. And this looks nicely counted by, so, and we can actually change the x-axis to 7. There we go. All right. Look at that. That's gorgeous. Okay. So now I'm going to graph that on my thing, but I'm only going to graph like starting here. I just wanted to be able to see it, so that's why I backed it out a little bit more. So let's go ahead and write down our window. So our x-min is -1, and our x-max is 7, and we're counting by 1. That's our x scale. That's the same as steps on this. The y-min is -10, and the y-max is 210. And I don't think a scale of 50 is very good for this. See, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if you do 210 minus -10, that's 220 divided by 15. So basically, I'm just trying to like figure out how many steps I want to take. So if I do, let me grab my calculator. Sorry, put that down for a second. That's a great video. Okay, so if I just do 210 minus -10 divided by 15. So I'm not assuming you have a graphing calculator at home. This is just, I mean, you could use your basic phone calculator or the one on your, just like Google calculator. Okay, so I'm going to count by 15s. Let's see how that looks. So back to here, I'm going to put my step, close that. Okay, I'm going to put my steps as 15. Now let's see how many I got. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think it'll fit if we do that. I'm now going to grab a pencil to graph this thing because if I mess up, I need to be able to erase. So if you're taking notes in pen, you should really do this part in pencil. Okay. So here we go. I just need -1 this way. And then, oh, now I went to -10, right? So I need to go up by 1. And then that's fine. 1, 2, 3. 1, 2, 3, 4, 5. Can't skip every other one. So. Okay. All right. So that is 1 right there. I'm going to label that. And then this is 15, 30. So if you do this and you say just like 0 plus 15, and it'll tell you 15, obviously. And then you do plus 15, and it'll tell you 30. And then after that, you can just hit your enter button, and it'll tell you the next thing. 45, 60, 75. So this is 15, 30, 45, 60, 75, 90, 105, 120. So what was that? 60, 75, 90, 105, 120, 135, 150, 165, 180, 195. Oh, I didn't See, that's why we did pencil. Didn't make it counting by 15, so let's count by 20s. Besides, that's easier to count by anyway. So let's come over here and say 20. Oh, I didn't write that out. Look how smart I am. Okay, so I'm going to try 20s. So this is 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. Okay. All right. So let's fix that on here. Just so my scales match. So I'm going to count by 20. Okay. Oh, and let's see. Well, that would mean I'd go down to negative 20 now, right? And what did that go up to? 200, 20, 40, 60, so 260. Okay. And then I actually went -1, -2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, this isn't actually a good representation of what we're going to see when we graph. Okay, so -1 actually is where -1.3. Okay, interesting. And then if I go 0, 100, look at that, it just pops up just like on the other calculator, 0, 100, 2.52. Okay, so 0, 100, 2.5, 200. And then keep going. And then 6, 0, basically. Okay. There we go. So this is actually -2 to 12 on a scale of 1. And this was -20 to 260 on a scale of 20. Okay. All right. So it showed the -1, but just because I got it in there when I was drawing it, but it doesn't say you can't. It just says to make sure that you get these in there, and I definitely have all of those in there. Okay, now it says the point 4.8, 115.36 lies on the graph of the function. What does this mean for the situation? Well, this is t, and this is s of t. So all that means is that, well, let's see, actually, 4.8 seconds after the ball is, or I didn't say the ball, sorry, the object is propelled, it is 115.36 feet in the air. Okay. After how many seconds does the projectile reach its maximum height? Well, where does the maximum happen? And what is the maximum height? So after how many seconds? Okay, well, that's just the vertex. Maximum is vertex. So it reaches it at 2.5 seconds. The object reaches or is at its max height of, and then what was it, 200. So that's all. So the y value is, so the vertex is 2.5, 200. And so you just use that to translate it. Okay. For what interval of time is the height of the ball greater than 160? Okay, well, you got to graph another one. So we're going to go here, and we're going to graph y equals 160. And there it is. So, okay, and we just need to know those two intersections. So, let's see, it intersects 0.919 and if you just kind of trace over, 0.4081. Oh, 4.08160. Okay, so for what interval of time? That just means give me the interval, all right? So the object is above 160 feet from 0.919 seconds to 4.081 seconds after launch. What is it? Ball's initial velocity thrown directly. Okay, after launch. Oh, and it is a ball. It said ball there. Whoops. Okay, anyway, object is fine. Okay, after how many seconds will the ball hit the ground? Okay, so after how many seconds means that we want t equals question mark, hit the ground, when y equals 0. All right, well, that's right there, which is the x-intercept. If you click back on the red one, the x-intercept is 6.036. Zero, 36, comma 0. Okay, so the ball hits the ground at 6.036 seconds. And there you go.